in the glider, or did that progression help you somehow?
I think.
Oh yeah, flying hang gliders. If you survive, you'll learn a lot more about the micrometeorology. And usually the easiest students to transition into sailplanes are ex hang glider pilots that had experience, so they pick it up a lot faster than power pilots will.
Yeah, that was what someone else told me.
I noticed when I went to a glider, you feel so much more from a power plane, and I've flown speed wings. They're like little parachutes, little paragliders.
Yeah.
A little bit, but you really feel things in those too.
Oh yeah.
Like the ground if you don't plan it right.
You really feel the ground.
So Bob, how long
And
did
the
you
same-
fly hang gliders?
How long did I fly?
Yes, hang
Are you-
gliders.
Oh, well, last time I flew one was probably 3 years ago.
Oh
So I
really?
still have mine. But I don't know, 40 years almost.
Oh really?
Yeah.
Okay, because I started in 79, so a little over 40 years ago.
That's when I started, 79.
Mhm.
So we probably were taking instruction at the same time.
Could have been. Could have been.
Yeah, what were the gliders like back then?
Well,
Gliders or hang gliders?
Yeah, good.
The hang
point.
gliders, sorry.
we're talking about hang gliders.
Yeah,
hang
that's what I
gliders
mean, the hang
were,
gliders.
they were single surface, 8-9 to 1 glide ratio, and
Mhm.
stored reasonably well. They just didn't have the safety items that the newer ones did. So,
Right, and they were was it the delta shape with, what was it, the regatta
Yeah,
wing?
I
Did
mean,
you fly
that's-
those?
yes, I did.
Oh. Well, I never flew in a delta shaped one. I'm trying to remember the brand of mine. Yeah, I never flew a delta shape.
I mean, they were all kind of delta shaped, but not the old 90-degree nose angle.
Right, that's
things.
what I'm
Those,
talking about.
Those were back in the early 70s, mid 70s. Those
Yeah.
were even more dangerous.
Yes.
And weren't the water skiers part of that? Like the kites
Kind
they
of.
pulled
Some
behind
of
the
those
boats?
earlier
Yeah.
ones were flat kites, so a little different
Oh, that was
design,
it.
but
Yeah.
kind of the same idea.
Well, champion, baby.
Can't even imagine.
In 79, we had progressed to wider wingtips
Mhm.
and with some dive recovery by that time. And, you
What does
know,
that mean, dive recovery?
that means that you had some little sticks at the end of your wingtips. So if you went, you know, too far nose down, it held the back of the sail up at the wingtip to lift the nose.
Oh,
And
so if you got going
sometimes it
too
worked.
fast, you couldn't overcome it.
Yeah, sometimes
have
it
to
worked,
confess-
sometimes it didn't
Oh.
work quite as planned with those sticks.
Oh,
Right. Well, it didn't work with the ones that had very low tip reduction angles there. But for the most part, by 79, we had kind of figured out how to get them relatively stable.
Oh, Al Godman.
Yep.
Yeah, okay. I don't know if you remember me, but I am Jerry Haney. I took lessons from you guys back in the late 70s and the early 80s, and
Hmm.
the Sky Sails and Mark and
Yep. Yep.
that's a long way
Welcome,
back.
Jerry.
I'm doing good. Bought 2 ultralights from you guys, so
Yeah, you were, you know, it was great interacting with you.
yeah, it was fun back then. Sure was. I think I remember seeing you one time up at Green Mountain Reservoir when we couldn't jump off of oh, what was the mountain up there right across from Green
Williams Peak.
Williams Peak, right? And you're down on the water in in one of the windsurfers.
Yep.
doing
Yeah.
that also?
Yeah, I would do both.
Mhm.
Hang glide when it was good and windsurf when it wasn't good.
Yep, yep, I remember that. Sure do. Gosh, long ways, long time ago, huh?
Yeah,
Second.
you, Bob, and I have been around.
On the floor.
Mhm.
Bring it down.
And in my most recent years, I've really gotten active in bicycling and mountain biking, so that's been a lot of fun. I'm having a hankering to get back in the air again.
All right, I'm going to call the meeting to order here in a couple minutes. We've got 60 some folks who've logged on, and I'll give it a couple more minutes. There's still people coming in, and then we'll call to order. We want to make sure we're recording this, and I think I've got it recording. Some of the co-hosts, like Clemens, I don't know. Clemens, can you verify that you think we're recording?
It looks like it's recording. I think at the end, they ask you whether you want to record it on your computer or to the cloud. And I pressed computer last time and that didn't work. So try the cloud.
Yeah, I did. And I did that at the beginning, and I put in cloud.
Okay.
That way we can all get better access to it.
Yeah, that's good. Yeah, that's good.
Let's hope it comes through this time.
Yeah, it does look like it's recording, but who knows? It looked like that last time too.
I know.
Well, it does say recording in the top left-hand corner.
Yeah, that was the case last time as well.
Yeah.
Problem.
It looked a little different though. We didn't get the ... after the recording. I don't know. We'll see what happens.
What you should get right after the meeting or within half an hour after the meeting is a link to the video and the audio that you can publish.
Okay. Well,
Maybe
we'll
I
do
look
that.
at I haven't looked at my spam folder. Maybe it's in my spam folder from last time.
Spam.
Okay. It's 5 after. If anybody else joins, we'll let them in. But first, I'd like to take a moment on some administrative matters. Because we have so many people on this, it would be great if and more coming in. So it'd be great if everybody who isn't going to speak would go ahead and mute. That way we won't get background noise. So if everybody would mute theirs except for Bob and myself for now, we'll go ahead and get started. First, welcome to the Ground School, the Soaring Society Boulder Ground School series. I've seen names come in, join us here, a bunch of people who are in the club and also many guests who are not in the club. We have, I think, 15 or so prospective members who want to join, but we don't have, because of the pandemic, we don't have the instructor capability to take them all in, and we're trying to we're doing some onesie twosies based on a variety of factors. So we're going to try to get as many people as we can who want to join to be able to join. So anyway, welcome to all of the folks who are prospective SSB members. We look forward to having you on board as soon as possible because of the pandemic. Also, we've got some other pilots from around Colorado and even outside of Colorado. I saw my friend Omri logged on. Welcome, Omri, and several others. We've got some pilots joining us from the Black Forest Soaring Society and also Al Canyon. And and also some other pilots around Colorado. So we're going to have in this series, you've probably seen from the emails, a number of different pilots who are going to give presentations. And I've been asked from time to time, like, how the heck were you able to round up all these good pilots and all these good topics? And the answer to that is they're all SSB pilots. We have just a great bunch of flock, if you will, of soaring pilots with really impressive credentials in soaring, and they do a lot. We're typically right at the top of OLC, online contest. We have about 24 pilots that fly cross country and have posted on cross country flights on OLC. And we have about another dozen that are up and coming. Some of them are my students who have just gotten their ratings, and they're scratching and itching to get out there and fly cross country. And we've got a great DG 505 trainer to help them get started, and then also 2 Schempp-Hirth Disci for them to go fly, and we want to see a lot of OLC points coming up. SSB is usually number 1 or number 2 in North America on OLC. I'm hoping that after this ground school, we get everybody fired up, and we will be number 1 again, and hopefully by a long shot. So we're going to improve mentoring as well to try to help everybody come along. And that's part of the purpose of this series. SSB in the old days, long before I got here, we would have a symposium similar to what we're doing now. And we'd pack it in, I guess, in a few days. And we did it. We had a great auditorium to do it in, which we no longer have. And based on the pandemic and the times, so this is kind of, we're doing it on Zoom. We're doing it on Zoom instead, but it's kind of the same series that used to get packed into a couple of days, and now we're doing it over a series of weeks. At the end of this series, we're going to have an open forum for everybody, and we want to talk about what you've learned, what you want to learn, what your goals are, and how we can get the mentoring going a little bit better. We're going to try to formalize the mentoring. You've probably seen we have a couple discussions in the series on mentoring. So next week, Colin Berry is going to be talking about how to plan out your flight. But tonight, our special guest and lecturer is Bob Faris. And Bob, of course, first of all, is our chief flight instructor, but he has a resume here that I'll go over. It's pretty impressive here. He has about 1,500 hours in hang glider that he started in 1979. 6,000 hours in airplane. He's an ATP, airline transport pilot, was a corporate pilot flying Learjet, holds CFIs in single engine, multi-engine, instrument, and glider. He's got about 6,500 hours in glider, holds a gold badge with 3 diamonds, and he's won 3 regional contests. This one is a biggie. He holds 89 state records in Colorado. I think that's more state records than anybody has. He's also currently chairman of the SSA Badges and Records Committee. And he gave the weather briefing at Nephi. So one of his great skills is in weather forecasting. Since we wanted to make this weather forecasting one of the first in the series, because you got to have good weather to soar. So Bob, you want to tell us how to go find that good weather?
Sure. I don't know if I'm the one actually doing the forecasting. I'm using other tools that are available to make forecasts. So tonight I'm just going to go over some of the things that I use and kind of get everybody, have them get ideas on how they can get their own forecasts going and relevant for them. So you're hearing me okay?
Yeah, perfect, perfect, Bob.
Okay,
Yeah, you're
I
coming
wasn't sure.
through.
Everyone's
I'm gonna-
muted,
We're all
so
muted.
yeah, the sound is great.
Okay, thanks. I'm going to go ahead and go to my shared screen and start a PowerPoint presentation on this. Let's see. Armand, can you enable my screen sharing?
Other than the recording, will this, your PowerPoint be available?
Yes, I'll make it available afterwards. So thank you. Okay, let's see what we got here. Okay, minimize. All right, I'm not able to get out of this thing here. It's not letting me minimize the screen, but let's see what I can find. All right. Okay, can everybody see that all right?
It says I'm seeing Armand's screen.
Okay, for some reason, I'm...
Zoom, edit meeting polls.
Oh, there we go. Okay. How about now? Are you seeing that now?
We see you.
You're seeing me, huh?
Not yet.
Okay, we went over this afternoon and it should be working. For some reason, let me go back to see what we have there. Okay, try again. How about now?
I still see you.
Trying to get rid of the
Try it now, Bob. I hit a different,
yeah, it was okay. I'm gonna give that a go. All right. How about now? Nope.
oh, shoot.
Not
This
sure
worked
what-
so well when we did it this afternoon.
Yeah, it was working fine this afternoon.
Well, maybe a lot of us should go to no video to help the bandwidth.
How about now?
Yep,
Did that-
Yeah, there you
perfect,
go.
Yeah, you did
perfect.
it.
Hooray!
Success.
All right. I'm going to get rid of my picture here. And so I can start this thing. All right. So we're starting out the ground school series today on soaring weather forecasting. Kind of what I'm going to go over today is looking at some of the different data sources for numerical weather prediction. Talk about that in a minute. How those fit into different forecast models. And then finally, those models will go into forecasting tools that we'll be talking about. I'm going to go over how I use the soaring forecast. Isn't necessarily the right way, it's a way, and kind of a flow on that. I'm going to go over a case study of a contest soaring forecast of a day out of Nephi, kind of show you how we used the weather to help us have a pretty favorable day, go over conclusions of this talk. And I've got a reference sites with hyperlinks, and I'll provide those. So I think there's some good ones. And if we have time, we'll go over some questions. So sources of data for numerical weather forecasts. One of the earlier ones was the radio sign. We still have those today. Of course, those are the balloons they send up. They go on up and they are hauling a long string so the balloon doesn't interfere with the sounding data. And they'll climb up, and finally the balloon will burst and it comes down in parachutes. These were developed in the late 30s originally. I'm sure they weren't as sophisticated as we have now, but it did basically the same thing. So we were taking data, they're taking data from temperature, pressure, dew point. The earlier ones were tracked with radio, but now with the advent of GPS and the cheap GPS receivers, that's taken the place of the radio tracking. The launches everywhere are done at 1200 Zulu and 00 Zulu worldwide, pretty much. There may be additional ones on occasion, probably if they have hurricanes or something going on, but generally that's done everywhere at the same time. The data collection starts from the release and goes up to sometimes over 100,000 feet, where the balloon expands to a point where it'll burst and it'll come down under a parachute. Sometimes they're collected afterwards. People turn them in. Most of them are lost, though. The thing to take away from the soundings, though, there's only 69 RAOB sites in the continental US. So there's a lot of distance, hundreds of miles sometimes, between these sampling sites. The closest one we have is at DNR, the old Stapleton site, North Platte, Nebraska, LBF, and Grand Junction, GJT. We'll go over how to pull those if you want to in a minute too. This is the primary data source for numerical weather prediction. So believe it or not, we're still using technologies from the 30s really for our weather. Weather satellites were kind of a big change, especially if we were looking at visible moisture clouds like from hurricanes. I think that was probably the impetus of putting up the original satellites. First of them were launched the Tyros series in '60. We had visible and infrared imaging from those. What was found back then is that by looking at the clouds, we were seeing wave images that weren't previously known from the ground, especially in the remote sites like out in the Sierra Nevadas and downwind from those. And they were able to get some pretty good wave flights just by looking at the satellite imaging. The newer satellites, we have the big geosynchronous satellites that are way up high, but then the lower polar orbiting satellites also provide higher resolution imaging, get temperature, dew points, wind, IR, and visible observations. They're limited sometimes if you have a lot of clouds by beam attenuation. So really, believe it or not, the sounding data, is really reliable. It can be sent up rain or shine and get the data every day. These create a very, very large data set to process for a lot of the numerical weather prediction models. So a lot of this data is left off really when we go to the modeling. Other data sources that are used in these models, ACARS data, those are data taken from commercial air flights, for instance, recording temperature, pressure, winds. It's all thrown into the model, along with real important one is the surface observations. Without those, of course, a lot of these wouldn't work at all. We have ground-based radar and some profilers that are around, but not a lot. So what do we do with all this data? We have numerical weather prediction, weather models. There's a lot of different models, and they're continually being tweaked and modified. New models are coming out all the time. So I'm just going to kind of touch on them. What we're looking for in a model is an accurate model without bias. That means we don't have optimistic or pessimistic trends in the model. We want something that's going to give reality. We want enough resolution for soaring analysis. So that's going to depend on what we're looking for. If we're looking for thermals, we can maybe get by with less resolution as opposed to looking at wave bars, convergence lines, which are going to require more resolution. We want to look at adequate time for our purposes. So if we want to decide if we want to take off work in 2 days, we want to look out and see if it's going to be soarable or not. Of course, we want to have it for at least for the day of flight. So that'd be the minimum over the course of the flight. But ideally a little bit more. As far as looking out though, for any forecast, the farther out it gets, the more of a guess it is. And I'd say anything beyond 3 or 4 days is pretty wild guess on a lot of times. Yeah, and I can show you some other data today that in a little bit, and I think it's wildly optimistic, but models break down just like any of the meteorological models. What's used by, I'm sure most people have heard of this, the Rasp and SkySight. It uses a WRF framework, and that's the weather resource forecasting. That was kind of put together at NCAR, NOAA, in association with some other groups to analyze this data. It's not really a model per se, but it's a framework that's used to make these work. A model that was used for initialization. Each of these weather forecasting tools will have an initialization from all the data sources that go into the model. In the case of the original Dr. Jack's blip map, it was the RAP initialization, and the Rasp has gone to using the North American Mesoscale and NAM initialization. And for the most part, SkySight, I think, is using the GSS model. It's based out of Australia, and it's kind of a worldwide more model, but they may use other proprietary things as well. Another model that's come into play in the last few years is the high resolution rapid refresh. And a lot of times you'll see huge variation, just like in any weather forecasting, between these various models. So sometimes they'll break down, sometimes they'll come in alignment, but it all depends on you know, how well the models are working. So what do we do with these models? We take them and put them into forecasting tools. So I think one of the most powerful tools that we can use is the modeled SKU-T charts. These aren't actually the sounding itself, but it's modeled from the sounding to give us an upper air chart. We're going to look in detail on this, on how most people probably know how to use SKU-Ts, but maybe not. I'm going to kind of run through it a little bit for everybody, and hopefully somebody that uses it even often will pick up something from it. This is a great tool for forecasting thermals, the strength, the height of thermals, and when to figure your launch times. The original Dr. Jack blip maps, those were developed by Jack Glendinning, who is a meteorologist. He is a meteorologist out in California, also a glider pilot, ex-glider pilot now. He developed these back around 2000, and it kind of revolutionized the forecasting tools that we used, at least in the US, for soaring models. These provided and they still do provide a nationwide coverage of a variety of parameters that we'll look at in a few minutes. They're fairly large scale, so the resolution isn't as good as some of the newer models, but it gave complete coverage that we could pull up, look at it. Everybody did it, and 15 years ago, and thought it was great, and they knew when to go flying or when to stay home. So we've improved on that now. Dr. Jack came up with the Rasp model. I'm sorry, let me back up. The blip maps were originally run on a single server that he kept, and he's kind of let that one fall by the wayside a bit. He's not making any changes on this, but he did develop in around 2006, I believe, the Rasp model. And what that was is a tool that if we had volunteers that would run on their own computer system, and they wanted to take a regional look at things, then they would run that on a daily, weekly, whatever basis they would like. And it gave a much higher resolution, no cost model. We're really, really fortunate to have Dave Leonard at Black Forest Soaring. He has taken on the job of running the Colorado Rasp, and he does it on a daily basis. It's great. There's 2.4 kilometer and 4 kilometer resolution. It's a tremendous aid in soaring. And like I said, if you don't want to pay anything, this is a really good way. Even if you do want to pay something, I use this all the time as well. Interface is easy to use. We're going to look at this as well. There were a variety of commercial soaring forecasting tools that have come out in the last few years. And the one I use is SkySight. It's $79 a year. It gives coverage similar to the Rasp, but it's nationwide. So you don't have to just be limited to Colorado. So if you're going out and flying other places, the Rasp that Dave runs won't work unless he happens to be flying at a contest, and then he'll usually support the Rasp for that area. The nice feature on SkySight is that you can download to LXNav products with a CU subscription and get weather overlays. So you could, if you had a CU desktop, you could overlay the weather on that for your flight planning. But the other really, really strong feature is that you can put it on like an LXNav 9000 or an UDI, and in real time while you're flying, see the weather forecast. It's not a real time, it's not collecting data as you're flying, but the forecast data that updates as you fly. So what I use it for, and probably most people do with the SkySight product on this overlay, is put the convergence models down. I'm still not totally sold on it. It can lead you down the wrong path, but it at least gives ideas of where to go. And if it's blue, you can use it. Sometimes it's great, sometimes it falls off a little bit, but it's a fun thing to have on your flight display while you're flying, some weather on there. Other commercial products, I don't use them, so I can't really speak of them much, but available like XC Skies, Top Mateo, and there's some others available. So let's look at some of our soaring forecast tools. I'm going to first pull up how we can use the SKUT and kind of go through that in a brief basis. So, let me get the right one here. So this is everybody seeing this one okay? This
Now we still see the presentation, Bob.
sorry, let me kill that. Somehow it paused the. How about now?
Yep, now it's here.
Okay. This is a sounding from that's generated on a pretty much hourly basis on some, or over the few hours on different models. But how this comes about we pick our data source here. It defaults to the OP40, which is good for a day model. I find that to be a pretty neutral model for Boulder. There's other ones that you can select. You can select the RAOB sites, or you can pick up like the NAM or GFS. But like I said, I would pretty much leave this on the OP40 and use that. It works pretty well. You can select the hours you want to look out. So the maximum for the OP40 is going to be 18 hours. And then down here, you can select the site that you want to look at. So it'll pick up the airports under the ICAO code. You don't have to put the K in though. You can put BDU for, say, Boulder. But you can also put lat long. So if you don't want to pick up a specific site, you want to like customize it. This one here that's highlighted is actually up close to Niwot Ridge. So if you put that in, it'll snap to the closest grid point to that and give you a sounding in the mountains. But let's look at a Boulder sounding. Go to interactive plot. Now, again, this is going to be winter. So most all of these soaring models are designed around thermal soaring. So although we have some wave flights in the winter, most of our flying is going to be thermal soaring, and this one's really directed at thermal soaring as well. So down in this lower table here, you can click on any time frame you want. It's all in Zulu, and the farthest one out, it's looking at 1800 Zulu tomorrow. So kind of, we'll just look at this as a rough basis. It's not going to give us thermals because there aren't thermals much in the winter, but how this is laid out, we have horizontal lines that are pressure in millibars they run across. The corresponding altitude is going to be on this side to the pressure gradient. So 500 millibars, half the atmosphere is below you. That's always the rule of thumb. That sits to be on this one about 18,000 feet. So 500 millibars, of course, to 18,000. 700 millibars is about 10,000. 850 is a little below 5,000. So if we see anything above 850 millibars, it's going to be below ground level here. This is a skew T log P chart. So this is logarithmic pressure on the horizontal lines, and the temperature is in Celsius on an arcing line. The red line's going up to the right. Other lines that we want to be concerned with are the dry adiabatic lapse rate lines. These are the blue arcing lines from lower right to upper left, and that defines how a parcel that moves up from the surface, or anywhere actually for that matter, is going to expand and cool adiabatically. An adiabatic process is just one where there's no exchange of heat with the outside, no mixing is assumed. So if we have a parcel at this point, it's going to move along this line. Actually, that's going to define the temperature as it moves up and cools and expands. So that's how we're going to be able to tell if thermals are going to keep rising or not. Go over that in just a minute. We've got these arcing black lines. These are the saturated adiabatic lines. Dry adiabat, it doesn't mean necessarily that the air is 0% humidity. All it means, it hasn't reached saturation. Once we saturate that parcel, then going through a phase change, and it'll start following the saturated adiabats up, because as you move up from there, you're squeezing out that moisture, and the latent heat of vaporization is huge, and it's going to change that profile. It's kind of hard to see, but there's some arcing, kind of a gray lines that move up there. Those are the saturation mixing ratio lines, and we'll use those to determine cloud base. So that's kind of the graph paper on a skew T chart. So over to the right, once based on sounding data, we have the wind velocity and direction as a function of altitude. We also have a graphical interpretation here. As you can see, we have barbs this would be kind of a west-northwest flow, 10, 15 knots, picking up to 20 knots. Once we get a pennant, that's around 50 knots. So it goes up pretty fast, almost close to 100 knots at 40,000 feet. If you forget what those pennants mean, you can put it over here. And this is the Java interactive plot. So it will give the direction and velocity right over here at any altitude as you move up. And it'll also give your temperature of whatever that cursor is pointing at. So on a day basis, it'll pick up the winds. This red line is the modeled sounding data. So that would be define the temperature of the air mass as it goes up. Temperature of the air as it goes up. So that's kind of how that sounding is going to define that as well. Over here is the dew point line. So the temperature which we would cool that parcel to at whatever point it is to reach saturation. So how do we use this? If we put in a temperature over here, I'm going to put a really unrealistic temperature over here so we can move this around to find whatever altitude. Actually, I'm going to do one other thing first. We're usually not concerned with the very high altitudes here. So if we want to scale expand it so we can see it better, you can left mouse click and drag this down and expand up that information so we can see it a little better. So if we move this cursor over to the field elevation at Boulder, about 5,300. Oh, by the way, this is not actually at Boulder. This will snap to the closest 18-kilometer grid. In this case, it happens to be 4.5 nautical miles at 74 degrees from Boulder. So it's really taking a modeled sounding out close to 287, maybe out somewhere in that range. Anyway, if we put a temperature, if we say, okay, tomorrow it's going to get to 70 degrees, 77 degrees, totally unrealistic, left mouse click it, then this defines how that parcel is going to move or how the parcel it will be going up relative to the environmental line as it moves up. So what we have here is a warmer parcel than the forecast environmental line. And that's called the thermal index. In this case, it's negative. So a negative thermal index gives vertical velocity to the thermals. So this is kind of an indication of rate of climb of the thermal. So the bigger this thermal index, the faster that parcel is going to move up, and the thermal is going to move up. In this case, as it comes on up, these start to get closer together. So the rate of vertical velocity of that thermal is going to decrease as we climb up. And then it'll finally get to a point here where there's a black line that's going to define the cloud base. And then with this, starts following the saturated adiabat above that because the air is totally saturated. So in this case, cloud base would be 15,375 feet. And that the way that's come about is by taking the surface dew point, moving along the constant mixing ratio line, and where those two intersect is going to be your cloud base. There's a variety of parameters over here. I'm not going to get into too much. It has to do more with thunderstorm activity in the summer. So it's really not very applicable. Now, what do we have really tomorrow? It's probably going to be 50, maybe 55, 60 degrees. Well, okay, I'll be optimistic. 60 degrees. We left mouse click. We have some thermal index down below, but that absolutely stops at 7,100 feet. So this is a thermal inversion as it moves across the adiabatic lines, and that's going to totally stop your vertical development from thermal lift. So again, you'd have to have some driving force across here because it won't reach that point. You got to have vertical motion to correspond to the sink rate of the glider. So we'd be lucky tomorrow if we hit 60 degrees to probably see 6,500 feet at noon. So actually 11 o'clock. So that's kind of in a nutshell how this works. I'm going to go ahead and move to the, can't quite see. There we go. The Rasp model. Are we seeing the Rasp model? Is that up now?
Yep, works.
Okay, cool. Finally working. Okay, this is from Dave Leonard's hosted site that he uses or that he's put together for us. It's in this case it showed the 2.4 kilometer grid. What we have on this is you pick the days along this point and then the hours in local time, mountain standard time along here for any time we want to see out. So if we pick today at 2 in the afternoon, actually over here, I don't know, everybody's picture's kind of blocking the view. There is a scale over here that's going to give the vertical velocity as a function of color. I can't quite see it because it's being blocked, but that's how that relates to this. To give you an idea of the scale of size for this chart, it goes up about Scottsbluff and Rollins on the north, almost to the Kansas border out by Lamar, to the east, down just short of Santa Fe to the south, and just past Grand Junction to the west. So it's a pretty large scale area for our flying. I mean, if you really get ambitious and you want to fly down way south to Moriarty or something, it's not going to quite encompass it, but it covers for the most part a lot of our flying. Other parameters that are in this, this is the thermal updraft velocity, the W, and that's probably the most important one once we get into summer flying from looking at this chart. Buoyancy shear ratio. What that is a ratio of vertical velocity to shearing. So again, I can't quite see the numbers, but the Dr.
You can move the box on the right. Just click on the box and it will move to the top. We can move the pictures on the side.
Put it over here. There we go for now. Oh, it's at the bottom. Okay, there we go. Can you everybody see this this now? Over to the right.
Everyone has to do this themselves, unfortunately.
Oh, okay. Never mind. All right. Anyway, the numbers here that are kicked out, the buoyancy shear is down around 0 for us in Boulder for tomorrow, as probably would be expected because there's probably not going to be much lift. This is showing maybe some some higher buoyancy shear, but probably very little lift anyway. So the rule of thumb, according to Dr. Jack, is if it's less than 5, it's probably not workable. I'm going to show in a little bit that that's probably not true in the really strong thermal days, but the takeaway, if you have a really high buoyancy shear, it's going to break up the thermal lift. And if you do have a high buoyancy or a low buoyancy shear number, and you fall out of that strong lift and have to work up down on the scratch up from the dirt and weak lift, you're going to have a really tough time. So if these numbers over on the buoyancy shear are low, try to stay as high as you can. Don't fall out. This has a couple other things, the height of critical updraft strength. So this would be the point where, as we talked about before, the thermal index is starting to fall off to match the sink rate of the glider. So in this case, the critical strength is assumed at 225 foot per minute sink rate. So this would be the expected thermal height that you would get. It looks pretty good. I mean, here we got some red lift over here to the west of Boulder, 13,000 feet. But the reason I don't use this in mountain flying, if we look at the depth of H-crit, that's AGL height, it's below 500 feet everywhere. So I would really recommend using the depth of H-crit if you're going to use this function rather than the height of H-crit. I mean, it's nice to know if you can get to 18,000, but when you're up there poking around the mountains, you want to know how high AGL you're going to get. Thermal height, that's kind of the same thing that we just talked about. Wind parameters, you can look at surface winds. You got 10 meter or 2 meter you can pick up. So we can see tomorrow what kind of winds we're going to see at 10 in the morning. Basically, over Boulder, it's probably going to be picking up 20 to 30 knots. So that might give you a clue that it might not be the best time. Again, this is at 2 in the afternoon. We can time frame shift this, like if we wanted to go to 11. It's still not looking good. So I'd be careful about trying to fly tomorrow. Another parameter that we want to use is the convergence line. That's just the meeting of air masses. Oftentimes we'll get a strong convergence west of Boulder, somewhere between there and the divide. And even if it's not usable purely to soar along, it will enhance the thermal lift. The other thing in this case, actually, divergence. So we're seeing 200 to 300 feet down along here, just on the lee side of the divide, and just on the west side of Boulder. So if you fly along a line of divergence, you're a $250,000 super ship that's 55 to 1 glide ratio, you might as well be flying at 126. So really avoid divergence lines when you're trying to plane your cross country. You've got cloud parameters, a variety of those. The one I use is the Q cloud base, where Q potential is greater than 0. Probably won't see anything showing up, but yeah, there's nothing there. But that's a real important one to see where that cloud base is going to actually happen. And if you use that Q potential greater than 0, that works pretty well. Anytime you have a question about any of these parameters with the Rasp, just go to this question mark and you click on it, and a window will pop up, and it talks about what each thing means. So that's a real nice feature. You've got wave velocities, say, of course, 1,850 millibar are going to be very helpful below ground level. If you look at vertical velocity at 500 millibars, 18,000 feet, that'll give you a pretty good view of your wave. Tomorrow it's not showing any wave to speak of. It's a really low foot per minute climb. These are, you can see the wind barbs. I'm not sure. Oh, I'm sorry, that's today. Let's look at tomorrow. That's when the wind's going to pick up.
Yeah, there's going to be wave tomorrow.
There we have a little more wave activity. 11 o'clock tomorrow. Boulder's here. So the winds at 500 millibars, actually, it's not showing a lot of wind. 30, 40 knots out in the plains, but kind of dropping off here. I don't know if that's true or not, but that's what the forecast is. This is drawing it through the max point, which is out in the Medicine Bow range. I'm sorry, that's not the Medicine Bows, but north of the Park Range. Walden's here. The zircles. That's it. It'll draw through the maximum point on that. Anyway, you can kind of see a little bit of wave bars up in here towards Fort Collins. So a hint of wave, not really strong though. I mean, this is 200 to 300 foot a minute climb rate. Again, not corrected for the sink rate of the glider. So it's not a super strong wave day. Anyway, we have a number of soundings available on this. Anytime you click on one of these little start areas, that will give a point sounding for it. Like we can view the boulder sounding. It's not the Java interactive one, but it gives an idea. And it's kind of an odd sounding to me. It's showing below 7,000 feet, the winds are going to be 50 knots, and then dropping off and then going north. Not a good wave profile, but I'd be really careful about trying to fly tomorrow with this 50 knot predicted low level winds. Anyway, in a nutshell, that kind of covers what Rasp will do for us. If we go to the SkySight, this is the commercial product version of Rasp, and it's not showing a lot happening way down here. But how this is set up, you have a time bar up here you can put in. You can pick your day. You can pick if you're flying a paraglider, hang glider, or sailplane. Changes some of the parameters. This one you can also change the model. The SkySight model, like I said, is using the GFS primarily, but we can go to the high resolution rapid refresh if we wanted to use that. What this has is let me look out a couple days. It'll be more interesting. There we go. A little more interesting in a couple days. So the forecast for a couple of days from now is a little more active. We'll take a look at that in a sec. But if we want to pick up a point skew T on this, anywhere you point to, you just click on it and it'll drop that skew T for you. It's a little bit of interactive, but not quite as nice, I don't think, as using the model skew T chart that I showed you before. But it gives you a pretty good idea, and you can just poke around any place you want and pick up a skew T fast. Point forecast, again, if you click on that, it'll give several days out and what the weather is forecast to be in terms of soaring conditions, height of thermals, etc. If we want to, let's look at thermal strength. This is the height of thermals, maybe potential flight distance. This is kind of an interesting one. This is the one I pulled up a little earlier, and I think it's lying, but we'll see. It's saying that if we go up in the Laramie Valley, you can see the little number. That says we can get 400K on Thursday in thermal flying out in the Laramie Valley. I'm not believing it, but that's how this forecast maps works for you. You can pick different areas, like here's 100 kilometer potential, out here nothing. But we could use that. In the summer, it's probably great. It does work really well in the summer, but I wouldn't use this probably for trying to figure how far you're going to go on thermal in the winter. So once we have, an area where you might want to fly, we can put a route forecast in. So this is a point-to-point setup. Let's pick up this is Al Canyon up here. So let's say you tow it up to the state line and decide you want to do a little route there, and you put your first point there and maybe over to here, over to there, and then back. And this will spit out a number for you. It'll tell you up in this upper right corner how fast a speed you can achieve over that route. If it goes to infinity, that means you can't make it around in that time frame. But launching at 9:30, we're going to average 51 kilometers an hour. It's going to take you an hour and 35 minutes. And as you come on down, you can see probably your optimum time, according to this, would be 90 kilometers an hour, launching at 1:30 in the afternoon. Take you 54 minutes to get around. Good luck, I think, tomorrow or Thursday if you try that one. Also, the winds are going to be blowing about 60, so it'll be tough. But like I said, this works great for summer soaring. So we can click on airspace, bring that up, look at a satellite overview. It'll pull up some webcams over here if we want to look at the webcams. On down, kind of the same sort of parameters that we looked at before, cloud base, things, ridge lift. It's probably not real useful for most of our flying, but it'll hint at places where you could get ridge lift based on the wind direction and velocity, and it'll give you your rate of climb at the ridge. Convergence. Okay, this one's, let me get rid of this screen. Going back to convergence, this will give you ideas of places to fly and your rate of climb over to the right in knots. We look at out of Boulder, there's a little patch of convergence here, 1.5 knots or so along here. Not a lot of convergence, not really aligned real well, so probably not a great convergence day. Wave cross section is another really useful tool that is in this one. So let me go to a vertical velocity first. Let's pick 19,000 feet and see if we can pick up some wave. There it is. Okay, so coming out of Boulder to the west, it's showing kind of a line of wave, Idaho Springs, maybe up towards Estes Park. And if we wanted to see how that's going to work along that line, we can go to the wave cross section, and you can pick a starting and ending point. So if we let's say we wanted to start up here, and we're going to run along this wave bar, and it's going to kind of give you a view of what the lift is going to be. Move your cursor along, you can see at this point 7.5 knots of lift, and up here over 10 knots of lift. Now the problem being, if you come all the way over to the right, that's at about 22,000 feet. So it's probably not accessible to us. So even down at 13,000 feet, which would be a big toe to get there, it's starting to fall off, and you may have a hard, even though there is wave, it may not be usable to you because it's too high. So that kind of in a nutshell is how Rasp and the SkySight works, and I'll leave it to everybody else to get more of the details on there. So I'm going to see if I can get out of this and go back to, I got to move this bar over here again. Put it out of the way somewhere. Okay. Good. Go back to our chart here, share. Okay. Everybody's seeing the PowerPoint now again?
Yep.
Okay, good. So I got it. Sorry, got to move you guys again over here. Okay. So what do we want out of our forecast? These are things I'd like to see. An extended forecast soaring potential. So we may want to look out a day or two, or even the full day of what's going to happen. So that's one thing I'm going to want to get out of. Time to launch, critical. So you don't want to waste your money, take a launch, fall back out, have to do it again. On the other hand, you don't want to wait too long and miss the whole soaring day. So that's something you want to get out of your forecast.
Yeah, bring him in if you want.
I'm sorry. Oh, height of lift. We want to see how far up we're going to be able to climb, and strength of lift, of course, the thermal strength. We want to pick a direction of flight, which way we want to go to enhance our lift and avoid the sink. Finally, you want the shutdown time. I've had times when I've pushed it out too long, too far, 50 miles out on the wrong side of the divide, trying to figure as the sun's getting low in the sky, how I'm going to get over that 12,000 foot peak. So you want to use your forecast to kind of reduce that happening. And finally, hazards to flight, thunderstorms, strong winds, turbulence, frontal passages. So you can get those from your forecast. And so the big picture is what I'm going to be looking at if I'm looking at a few days. Pull up the prog charts. It'll give you a lot of great information. It'll show you frontal lines as they're progressing, weather that may be happening with it, troughs and ridge lines. So you can kind of, I would look at that a few days out. It'll go out 7 days and kind of see what's coming towards you. Area forecast discussions. What these are by the National Weather Service are detailed discussions of the data based on the data that they're seeing of how the forecast is going to work out, if it looks good or if it's not looking so good and why. So you can get a lot of insight into how those forecasts are done by going to the area of forecast discussion. There's a variety of extended forecasts. You can get it from the Rasp, the sky sighting, and you can even look at the TV and kind of see if it's going to rain or not. But anyway, look out a few days. Again, the farther out it looks, the more uncertain I think that forecast is going to be. Winds aloft, critical in our flying here to know what the winds are doing, both in terms of successful soaring as well as safety. So we want to know those, and I want to see what's kind of coming in. I can look at the winds aloft all the way from the surface up to 60,000 feet and look at those few days out and see what's happening. As we get to the day of flight, I'm going to pull up the METARs of areas that I'm going to be flying. I can look at the Boulder METAR, and whatever, if I'm flying down to Slide, I can see that, and any other airports around. Terminal aerodrome forecast, the closest one we have is BJC, Rocky Mountain Metro. Even though it's a very few miles away, sometimes the weather there is quite a bit different than we get just because it's a little higher, but it'll give an idea of what's happening through the day. Want to look at the current winds and the winds aloft, both on the surface and as we push on up. A really critical thing if you're flying at Boulder is take a look at this NCAR Mesa Lab wind. It'll push back as far as 24 hours previously, but there are days that we'll see winds at NCAR, which is only 800 feet above us, 50, 60 knots, and it'll be light winds out of the south or light winds out of the east at the field. So do you really want to launch in those conditions when you're climbing up through that shear to hit that stuff? The other thing, as that mixes down potentially through the day, you might have to land in that wind. So you want to really be careful of what's going on up there. I look at the modeled soundings, of course, like we talked about, and the variety of the numerical weather prediction tools, Rasp and/or SkySight that I use. And then don't forget to go out and look at the sky and see what the clouds are doing, how they're building, how they're dissipating, what they look like. If they're really ratty looking, it's probably you're gonna be in for a rough ride. Or if it's smooth edged and everything's flat bottom, you're gonna have good thermals. So don't forget to look at the sky. Really critical. And as you're flying, of course, that's really takes over all the forecasting, moving to actually cloud reading. Then go fly and make your flight, your cross country flight you want to do, or your local flight, and validate the models. So see if they worked or not. And then go back to your model and adjust it for the next day or the next week or whenever you fly again to say, oh, that was pretty optimistic. Maybe I'll back off a little bit, or way under predicted. I want to move up from what it was given me. So that's kind of how I do a model forecast. Now, I'm going to give you a case study of, sorry. Move this down a little bit here. There we go. NEFI 2018 Sports Class Nationals. We were kind of getting towards the end of the meet, and we had a pretty good week. A lot of blue days, a lot of wind. This was day 8. So I'm going to kind of go over how we use the forecast model to task it and how it worked out. So what we had based on, I'll show you in a few minutes how we picked up this data, but fairly strong winds, greater than 20 knots, were showing, and it was going to be blue around NEFI, no clouds at all, and everything was going to start pretty late, fairly strong inversion. We did see a really high Q cloud base out to the east of the NEFI area that looked pretty good, and we had moderate thermals. I mean, for NEFI standards, 6 to 7 knots, and I would say that's moderate. I mean, out there you can get 10 knots plus. So it was a good thermal day, but not fantastic. A really key to this forecast were showing of the convergence lines to the east on one of the charts. The other problem we had, and we had it all week, was the large fire TFR that was sitting to the east of NEFI. And we had to deal with that. In a contest, you cannot overfly a TFR. You'll lose all your points for the day plus 100. So you're better off not launching if you overfly at TFR. So at any altitude, you cannot overfly TFR. So we had to take that into play. And okay, so what we had, first of all, we'll look at the soundings. Everybody can see the sounding there? Yes.
No, not yet. Nope.
Okay. Let me try again. New share. There we go. How about now?
Yep.
Okay. So this is the 11 o'clock sounding for Nephi for that day. We generally had a southwest flow, 10 knots or so, all the way up. The environmental line, of course, is here. And then it kicked as the inversion at about 8,000 feet. And that would suppress any thermal development at 11 o'clock. Very dry day. The dew point was down around 30 degrees. So we weren't going to get any clouds that day. I mean, if you follow the mixing ratio lines, they would have formed up around 20,000 plus, but we never had any clouds at all. The next slide here is a 1200 mountain daylight time. We were starting to see a little bit of rise in the inversion, but probably not enough to launch yet. Starting to kick out the inversion at 1 o'clock. There's just a little bit of a knee here up at 12,000. So, but looking better. So what you want to see is the environmental line paralleling the dry adiabat, which it was pretty much, and then it was cutting it off around here. And finally at 2 o'clock, things are looking pretty good. We're moving on up. We don't have an inversion until almost 16,000 feet. So 3 o'clock in the afternoon, pretty much similar. And then 6 o'clock, we wanted to pull this up, see what it's like as we're coming back. Still looking good. I mean, we're probably going to see 16,000 feet, although no clouds, coming back in late in the day. Everybody's kind of in the way. There we go. Okay. So, okay, are you seeing the boundary layer wind chart?
No, it's still the SQT.
Yeah. Okay. New share. There. Okay, now you're seeing it?
Yep.
Okay, so here are the winds as we were talking about, 20 knot winds plus through the day. This is kind of hard to see all the details on this, but this is the Great Salt Lake, Provo Lake, and then Nephi is sitting right there. So at 3 in the afternoon, 1500 Mountain Daylight Time, fairly strong southwest flow, maybe 15 knots around the Nephi area. But as we moved out to this area to the east, picking up quite a bit, over 20 knots, down the Henry Mountains, well over 20. This is the Uinta Range up in here to get a perspective. Duchesne Valley through here, Price right in this area, and the Capitol Reef, if everybody's been down through there, right through here. So pretty rugged country out there. You normally wouldn't want to be poking out there unless you had a pretty good day happening. Buoyancy shear. Okay, here's what I was talking about. The buoyancy shear on this day, as we got out to the east of Nephi. Nephi is here. It was down around 1, 2, 3, definitely below 5. So looking at this, you go, it's probably not going to be workable. Well, it is. When you got lift at 6, 7 knots, you can work it even with low buoyancy shear. So take that 5 as a buoyancy shear number with a grain of salt. Just be sure you don't have to scratch out the dirt on those days. So the height, the critical updraft strength, Nephi in this area, just kind of like the SQT showed at 3 in the afternoon, it was around 15,000, which aligned really well with the model SQT. So we went out towards Delta, it was much lower, so we wouldn't want to be pushing a contest out to there, especially with it being blue. But as we moved back to the east, we had very high workable lift up to 19,000 plus. Here's kind of the thing that made this forecast, I think, really worked well for this day. We had a series of convergence lines or could be cloud streets, but probably convergence more than anything, just based on where the desert air is flowing in. We had some along in here, but a lot of possibilities of working lift in a line. With that really strong southwest flow, excuse me, we wanted to be able to buck up against it with some additional lift. So these convergence lines kind of showed that we could do that maybe. That's what kind of we were based on our tasking on. Thermal updraft velocity, again, once we get out into the price area, 6, 7 knots, maybe 8 knots at times, looking pretty good. Some weakness. Oh, by the way, the TFR was sitting right there, and it was big, and it stayed all week. So it kind of cut off our normal tasking. Normally we'd run over here down through this range, but we couldn't do it because of the TFR. As we get into later in the afternoon, 5 o'clock in the afternoon, we can start to see the thermal velocity falling off somewhat, although it's still staying pretty good in the price area, up at 7 knots, 6 knots, but going more green down to 4 knots, maybe a little less as you push back to Nephi. So you kind of would want to be on your final leg or wrapping things up so you don't get caught out too far by 5 o'clock in the afternoon. Q cloud base. This was really, really good. We wouldn't want to be sending people off into no man's land, which this is no man's land at times, without having some cloud markers. So that's what we did not want to push out in the desert to the west and southwest. But to the east, we had good cloud base at 3 o'clock in the afternoon, showing base up around 20,000, 21,000 feet. Really good looking day. Up in the Uintas, even the lower part is still 18,000. So that was excellent. It was starting to fade a little bit at 6 o'clock in the evening, but still showing some pretty good clouds all the way down. This is down towards Loa and Wayne's Wonderland's little airport down in there, Capitol Reef all through here. So what did we task for this day? Let's go back to the convergence line. So out of Nephi, the task committee, we pulled it together and decided to do, we usually use turn area tasks in the sports class because of the different handicaps. That's probably the most popular tasking. So we had a fairly small turn area task out in this area, so we could fly there and keep out of the TFR. Then from there, we turned up towards the Uintas, had a big turn area task here, another big turn area task over here. So the idea was come out north, over to the east, down out into the kind of southeast of Price, and then work back over across Wayne's Wonderland. This would be southeast of Richfield, and had a pretty big turn area task here, and then back home. So probably normally from old forecasts from years ago, we would never have thought about trying to attempt a task like this. It just wouldn't be something, you know, seeing how blue it was going to be. Probably would have had a dump task, just staying locally, flying around the ridges and just hope for the best. But we were able to utilize this thing in our task call. So how did it work out for us? See if I can get out of this without having to go through the rigmarole again. New share. Okay, so here were the results for the day. Everybody can see the results?
Yep.
Okay, good. So what we had for the day were 21 competitors that launched. We had a few that dropped out by then, but we had one competitor that elected to not start the task. He decided it wasn't for him, so he did not fly. The other 20 started the task, 100% completion of the task. The farthest distance flown for the day was just over 400 miles, statute miles, not kilometers, miles, at a speed of just under 100 miles an hour. So by being able to utilize the forecasting that we have available, we were able to get a really good contest out of this that we probably normally wouldn't have been able to with the old forecast models. So anyway, that's kind of how this was a 4-hour task. So it's very similar to what we would be using flying on a day-to-day basis out of Boulder on a moderately good cross-country day. So using the same type of forecast as we would for flying a contest works out well for recreational flying as well. I go back to okay, are we back on?
Yep, back in the presentation.
Okay, good. Thank you for the help on this. Move this thing around again. All right. So conclusions. So what I would try to pull out of this maybe is find the forecast tools that work for you, whether it's Rasp or any of the other available sites, and practice using them, even on days that you're not going to fly. And then look at the clouds, see if it holds, or look at other people's flights and see if it matches what you forecast. So become proficient at that, or if you go out there and don't use these tools at all and then try to make it work on the day you're going to fly, you're going to be frustrated. The model sounding data provides a great tool for figuring when you want to launch and where you want to tow to. Don't get overwhelmed by all the weather information. There are tons of parameters that I didn't even look at today that really I don't use. If you go through all this stuff, it's analysis paralysis. So just use what you find works for you and understand it. Use the appropriate forecast data for the flight you plan. So what I'm saying by that is don't necessarily use the Rasp and look down at it in New Mexico and see how good it is if you're going to do a 2-hour soaring flight around Boulder. Also, don't think that you have to launch it right at 11 o'clock. That's, you know, when we're able to get onto the tow list and start flying. You'll see a huge number of people sign up at 11 o'clock and take a tow way back to the divide because everybody else was doing it because they were trying to get away early. And then they go for a 2-hour soaring flight. If you just wait a little bit until the afternoon for it to build in, you'll save yourself a lot of money and have a fun flight. So use the data appropriate for the flight that you want to do. And if you use the right forecasting tools, you can reduce your stress a lot, have a lot more data that maybe will help you in your flight, not overextending it or underextending it to utilize the whole soaring day. And finally, there's some reference websites. Again, I'll make these available after this talk. I kind of just want to say what they are. This first one I would highly recommend to everybody. It's not just soaring forecasting, but it talks about all the different types of lift, how it works on ridge soaring, thermal soaring, wave soaring. Gets into the performance of gliders. This is an OSTIF presentation that was done 10 years ago, but it's outstanding. I would recommend everybody look at that. It's about 80 pages. It gets the second half of the presentation gets into quite a bit of technical detail, but still usable for pretty much everybody to look at. Ty, one of our instructors, put together this site primarily for paraglider pilots, but everybody can use it. It's kind of it brings together all the different resources in one place that you can look at. I recommend that a lot. He also has about a 45-minute video that's very good on soaring around on the Front Range. Clemens has an excellent site and it's Just in the Air series, our website on meteorology that talks about ridge lift, convergence, and wave lift. So you can kind of get a lot of insights from that. Excuse me. This is the ADDS site. Gives you a lot of the information that I pulled up talking about prog charts, winds aloft, has thermal, has cloud charts on it, both visible and infrared. One of the things I like to look at it in a summer day when we've got thermals based on thunderstorms moving in or something like that is looking at the water vapor loop, and you can kind of see where that's progressing. So all those things are covered in this. The Colorado AWOS data has all the usable AWOS sites through the whole state. I used to use the NCAR data at the surface of Boulder, but that website or that weather anemometer went down about a year ago. So you still have the AWAS data available here. There's a variety of SSA tutorials on this site. Here's the link for the RASP. There's an old RASP and a new RASP. So Dave had this one originally on the old one. It's a little smaller area. It'll run pretty much on any machine. Sometimes the Google Maps has a hard time loading on the new RASP. So if you have an issue with that, you can fall back to the old RASP Univiewer. This is the sounding data that I used. Have a SkySight manual here. History of soaring weather through the years. That kind of gives you a good overview of how this has progressed. Again, it's a technical soaring paper, but it's a very good paper. Walt Rogers gave a couple of presentations, 2016, 2018, of all these different tools. Quite a bit of detail in it. Worth looking at, though, if you want to get a little more in depth on it. And finally, Matt Scudder, who put together SkySight, had a 2018 presentation. So that's about it. I'm going to open it up to questions.
You may have to unmute your microphone if you have a question.
So anybody have any questions? I covered a lot of ground, so like I said, don't get overwhelmed by it. But use some of these tools, understand how they work, and have fun with it. No questions. Okay.
All right, well, if there's no questions, or there'll probably be some that come up here, this is all going to be on the SSB website.
Or actually, is it going to be on the website, or I'll put this out as an email to the SSB members? What do you think?
Okay. Yeah, go ahead and do that. That'd be great.
These links I have are all hyperlinked, so you can just click on them and go right to it without having to type in the URL. So that'll save a lot of time if people want to use that.
Hey guys, I have a question. Bob, can you talk about the SKU-T and like what the SKU-T would look like on a day that was like real low ceilings, like a cold winter's day with no lift, as compared to like a real booming day in the summertime, and what like the differences and the visual of what the SKU-T would look like?
Well, for it to be low ceilings, you have to have moisture. So I don't have. I mean, if I go back to the SKU-T, let me show you first of all. Let me go back to that. Nephi SKU-T, because that'll show you what a good thermal day will be. Let me put some parameters in on that and show that. So let's see. Where are we here? Get rid of this thing. Okay. Okay. So here's the 1800 SKU-T from Nephi. This would have been an outstanding day with a few changes to this. First of all, it was almost 18,000, but I'd like to see this line going up to 18,000, just so we can get the full height out of it. And I want to see some clouds. So, well, ideally this would have been a much better day had this dew point shifted more up in this area where we were looking, maybe 40-degree dew point or more. Then we would see clouds forming up. Now, the problem with that, if you have a situation that doesn't stop the vertical development and you've got a lot of surface moisture being brought up, it'll just blow up into a thunderstorm and just go right up. So what you want to have is this environmental line capping it to the right to eliminate your big vertical development of thunderstorms. So in those cases, you'll have your parcel move up, form a nice Q cloud here, and kind of dissipate. And then you have just a beautiful puffy Q day to go fly, no hassles. If you don't have, like I said, with a lot of moisture and you don't have capping, it'll blow up. So what you kind of want to look for is a situation where the dew point is high enough that it'll form the clouds, and then it falls off dramatically and dries out with altitude. The other reason you want to have that is if you have your dew point line kind of following your environmental line, you'll get a lot of spread out, high altitude clouds, cirrus way up, and mid-level clouds, and that'll shut off your insulation to the ground from the sun and reduce or eliminate your thermals. So that's kind of an idealized summer QT. I don't have one for winter, but if you have in the winter, if you have your dew point over here right up against your environmental line, you're going to get a lot of low clouds. And then the typical wintertime environmental line is going to be that strong inversion that'll never break. You'll never have enough temperature to break through the inversion. And you'll get, maybe you can poke around down at 1,000 AGL below cloud base and move around in the lift, but you won't be able to go anywhere or get up through that.
So you want the temperature line starting bottom right, going kind of towards the upper left to a point, 18,000, 20,000.
Well, yeah, I mean, I like to see, especially if I'm going across country over the mountains to 18,000 feet, because you want every foot up there, because our mountains are 14,000 feet plus. So if you're going out in the plains, you could get by with a lot lower base safely, but up in the mountains, you want a high base.
Bob, am I reading this correctly that you need to have over 100 degrees Fahrenheit for it to go?
On what are you talking about?
On this chart, right? Yeah.
No,
let me get you out of the way here so I can kind of see. No, remember those are SKUTs.
Right.
So it would be probably on that day, it was close to 100. It was a hot day. Yeah, I think you are reading it pretty close. It was in the 90s there. So we were probably working around in this region and moving up along here. So, but remember the temperature's on skews, so it's not vertical. So, 80 degrees line would be here, probably 90 somewhere around in there. So it was a little over 90 probably that day.
Okay, thanks.
Anything else?
Bob, I've got a question. Can you hear me?
Yes.
Awesome. Hey, we struggle a lot in Steamboat with start time, and it varies dramatically based on when the inversion breaks. Can you just talk a little bit more about, predicting that start time versus, analyzing the SKUT, and then, if you have to make those manual adjustments because it didn't work out the way you predicted, how do you do that?
You guys got a tough problem. I try to avoid where you fly because it seems to not be so good there a lot of days for the reasons you just described. It seems like there's kind of a persistent inversion out in the valley. All I can say is, use that SKUT and look at it and see day to day how it's going to work out for you. I mean, some days I'm sure can be outstanding there along the Yampa, but other days it just never seems to work really well. I think there's a lot of moisture out there and kind of damps it down. And off the winch, you're having a tough time dealing with it. I feel for you. I know what it's like out there. I've scraped around in that valley low a lot of times, but all I can tell you is if the SKUT says it's going to be inverted all day, it probably will be, and you're probably going to get stuck and have to listen to us flying at 100 knots at 18,000 feet, 10 miles away in the mountains somewhere. But that's kind of what you're stuck with, I think, there, and until you get a tow plane. That's what you're going to have a lot of days, I think.
Gotcha. Okay, thank you.
Anything else?
Yeah, Bob, could you go over that again about how you would know if the clouds that you're seeing are going to blow up into thunderstorms?
Okay. What you want is, once you get the clouds forming, much beyond that point, you want to have the environmental line crossing your adiabats. That's called capping. That's going to limit your vertical development. And if you don't have that, if it somewhat parallels either the dry or the saturated adiabat, there's not going to be any stopping it. Remember, when you get a phase change of water, it's 540 calories per gram being released into that cloud. So you're adding all that energy, and that's turning into vertical velocity. So, if we had enough moisture on this day, it probably wouldn't, it might have blown up pretty big time had this dew point been up here where it's, forming clouds and going on up. But you know, ideally, like I said, you want your environmental line coming up and then moving off across the adiabats to cap that lift. Does that kind of make sense?
Now, is the vertical development of a cloud, that's part of it, right? Because in Florida, those clouds get real tall real fast.
Same thing. They have a lot of moisture down there, and if there's no capping above, Florida has some of the highest number of thunderstorms anywhere in the country, and you don't want to be flying those. It's hot and humid there, and there are a lot of clouds.
But my point is, you can see that, right? When you see huge vertical development in a cloud earlier in the day, it's probably going to max out early or overdevelop, right?
Well, yeah. I mean, it's if you see thunderstorms at 9 in the morning, it's pretty much overdeveloped already.
Yeah, I get that.
But this is a desert, desert skew T. You won't see this in Florida. You'll see it down here at a couple thousand, 3,000 feet, and then your thunderstorms are developing. It'll go to your saturated adiabat and go right up and blow up. That's when you start to take into the parameters of your K for your probability of thunderstorms, your total totals, your Showalter index. Those are all talk about your thunderstorm severities and probabilities. Those are on the right side of those skew T charts.
All right, there's one administrative thing couple administrative things I'd like to do. Can I stop your sharing, Bob?
Sure, go ahead.
Yeah, I wanted to do this poll on when we should have this, but now it's telling me you're logged in from another device. I don't know what happened, but I had this poll ready to go on whether we should hold this at, 4 o'clock, 5 o'clock, 6 o'clock, 7 o'clock, or 8 o'clock. 4 o'clock's probably way too early. I had this poll all ready to go, and then it says I'm logged in from another device. So I don't know. We'll have to try it again next time. Colin, I see you here. Do you want to give us Colin's going to be
Hey, Armad, I think I have your poll here.
Oh, can you send out the poll then?
Yeah, launch the poll. There we go.
Okay. And Colin, Barry is going to be giving the lecture next week on using CU, and that's has to do with the planning tool, not the college. And Colin, do you want to give us a teaser of what we're going to hear next week?
Yeah. Can you hear me?
Go ahead.
Okay. Next week, I'm going to complement Bob's presentation, because what we're talking about in these early kind of seminars is how to prepare and plan your flights. Later on, we're going to move into, sort of Clemens are going to talk about land outs or whatever, but there's a progression forward. And Bob's covered the weather, so this is where you really, as you get closer to your launch day and launch time, you're looking at that weather. But what I'd like you to all think about is having a plan as you come days before you get to the airport, where you're going to fly, and when you get to the airport, drawing up all these resources, then picking a direction and going and flying it. And that could be, if you're planning, you're normally trying to do something. It could be like you're going to get a badge, you're trying to get into the wave, you're trying to fly a big cross-country flight. So I'm going to try and cover levels for people in bucket 1, as Clemens would describe it, and people in bucket 3. The bucket 2 people, I think Clemens wrote them off. But, so if you're a newbie or an experienced pilot, and just showing you how to plan, tips on using the C product, and talk about what you do to get that integrated into your flight computers.
So that's what's coming up next week. We tried to put these first two. One is the weather and how to get an idea what's going to happen with the weather. And then secondly, where you're going to go once you know what's going to happen with the weather and how you plan that out. So was everybody able to get the poll? I wasn't.
It doesn't seem like it. I mean, the poll seems to be running for 2 minutes and 30 seconds, but no one has voted on it.
Yeah,
I voted and submitted, so I don't know.
Yeah,
Oh,
this
really?
is-
It
I
says
voted.
0 out of 54.
I voted.
And the
I
poll,
voted. I wanted to pick 6:30.
it doesn't.
You're the man, Bob. You're
It
the man,
didn't.
Bob.
Sorry, guys, it did not work. It just shows 0 people voted. So somehow this doesn't work.
Yeah, I voted as well. I guess it didn't go.
Yeah, I would recommend 6.
6 is good for me.
6 is good for me.
I like 7.
I do too.
6
Seven's
is
good for me.
I like
Maybe
7.
try the poll next week again and see if we can get it up and running.
Yeah, we'll probably leave it at 7 for now, unless I get a flurry of emails or something. But yeah, we'll probably leave it at 7, and we'll see if we can overcome the poll, the technical of get the poll working. And you know, it's hard
Well,
to pick a time for everybody.
The poll just showed up again.
Same for me.
I tried to launch it again, but I still don't get any responses that show up on the. I don't know
About
what,
recording, Armand.
I don't know why
Well,
this doesn't work.
it says it's recording. Okay, we thought Clemens was handling it last time. It wasn't. No, I'm just kidding. No, both Clemens and I thought we had it recording last time, and we didn't get a recording. So it says it's recording on my computer and in the cloud, but it says it's recording. We'll find out when we all drop off here.
Hey, Trump's not going to like me because I voted twice here.
So who is the host of this?
I'm the host.
Okay, you should get the Zoom recording.
Yeah. Well, we'll work on the technical, Jack, and we may have to bring you in on it because make sure we get it right. But anyway, we're working on the technical. There's a learning curve here with doing not just Zoom, but how to do a session like this with a lot of people. But so far, it seems to be off to a good start, and we look forward to seeing everybody again and having this series go on and highlighting our great pilots here at Soaring Society of Boulder.
I've got a question before everybody goes. The presentation I'm going to give is going to be use the full real estate of the screen. When people looking at Bob's presentation, did everybody see everything like in a 16:9 format, or did some people have smaller screens? I can't think there's that, but I thought Bob had to move stuff around to let people see it.
It came through fine.
Okay, I'll work with what was working out.
Around was the photo box for everybody. And you click that box left hand corner, you can minimize it and change its format.
That was Darth Vader.
Yeah, it was just garbled.
Stephen Hawking.
Whatever somebody said was just garbled. All right. If there's nothing else, we'll sign off and we'll try the poll right off the beginning next time. And maybe that'll work better. I don't know. I had the poll all set up to go. It just.
Yeah, well, thank you, Armand, for organizing this. And thank you very much, Bob, for the presentation.
Wow, that was wonderful. Thanks so much.
Much
Thank you,
appreciated.
Bob.
Good job,
Mark.
Bob. Thank you.
Thanks very much.
Armin,
Thanks for the lessons.
Yeah, thank you very much.
Thanks to everybody in
Armin,
Boulder
send
too
us out
for,
an email and we can vote.
Yeah, and then I'm going to get back 70 emails.
Life's a bitch.
Maybe
Yeah, well, if you're in charge, you got to expect
I
that.
know. Yeah, I know. I'm getting the big bucks for this, so yeah, I ought to do it. Yeah, we'll try to get the poll next time and see where it goes.
Armand, we could do a poll with Google Forms. Very easy to do. I can help you.
All right. Yeah, Clemens will head that one up, and we'll do a Google poll and send it out to everybody. We're also going to, we'll have a lot of graphics, handouts, whatever. And I'm going to try to get a special section on the website where we can hang everything for this ground school, because there's going to be a lot of good information coming out, and folks are going to want to get back, pull it back up again. So we're learning as we're going. So thanks everybody for your patience, and we'll see you again next Tuesday.
Well done, Armand.